Hi, in this video I'm going to show how to get a working development environment using this Bootstrapper to get Neovim development environment for Go. It could be extended to anything else, but I'm focusing just on Go as it is what I work with. So to start, I'm just going to copy this command. It is telling the command line that it has to clone this repo into the .files hidden folder that I just cloned. And here is just a matter of typing ./bootstrap.sh, and it's going to ask for the sudo password. The script is designed to detect the operating system. In this case it's Debian, but it works also for Ubuntu and Mac. In this case, for Debian and Ubuntu, it first updates the system, installing required software to go with the rest of the installation. So basically here I'm installing git, curl, wget, build essentials, and other stuff. If you are on Mac, it's going to do the same, but basically it's going to start with the homebrew installation right away. But for Debian and Ubuntu, I really need this so I can download the installer for the homebrew. I'm going to pause the video constantly just to skip these long processes, but I will resume once they have finished. So I will wait for this to install all the things that I need for Debian and Ubuntu, and then the next thing is to download the homebrew and its installation. The good thing is that the bootstrap command is going to do this automatically. For example, here we can see that it is downloading the homebrew installer, and after that it's going to start installing the packages that I have set on the brew file file. So I will just pause and then I will show just a sneak peek of how it shows the installation for each one of them. Now that homebrew is installed, it is reading from my brew file where I have the definitions of all the packages that I need to install using homebrew. The good thing about this is that centralizing those packages in a single file for this installation allows me to install exactly the same software in both a Mac or a Linux, so I can rely on this step to have the same installation across my devices. So right now I'm just going to stop this again, and I will resume once it has installed all the packages that I have set in the brew file. Okay, the installation of all the brew file packages is almost done. Actually, it's just finished. And now we enter into a step that it's important. Now we are going to source all my configuration files into the home directory. Here it is showing me how it's going to proceed. It's actually creating symbolic links into those files inside the repo. So for example, my git configs are going to point to this location, my CHS configuration is going to point to this one. The same is going to be for power level 10K, tmux, and other configurations. The special one is of course Neovim, and I also have a binary folder where I have a certain useful software written by me. I'm going to source everything of that, and the next step is to download all my CSH, which is the one that I use to make CSH more interesting. Now it is asking me for my password. This is important because this step has to do with changing the default shell. So now it goes from bash into CSH as default. Now we are downloading some plugins and scripts for all my CSH. We are installing some nerd fonts. We are installing the plugins for Tmux, and with that, that's the whole installation. There is nothing else to do here. So for Ubuntu and Mac, it is only necessary to log out and log in, but for Debian it's necessary to do a reboot. So I'm going to reboot the system, and we're back. So I'm just going to start the session, and I will perform some last configurations to my console. I'm using console because I have Debian 13 using KDE with Plasma, so that's why I'm using this one. So the first thing that I'm going to do is to create a new profile that I'm going to use as the default. I'm going to check it as a default profile. I'm going to change the color combination to solarized, and then I'm going to use the nerd font that I have installed before. I'm going to make sure to use a bigger font for this, and that's it. So you can see here that it's source. Finally, I'm just going to do some final updates to my system, and this is going to take also some time, so I'm going to pause this and I will resume once it's finished. Probably I'm going to reboot the machine one more time, so see you then. Okay, we are back. So what we have, so this is the whole thing. We have really nice working development environment. So for this I'm going to show a couple of things. So the first thing is to start Tmux. Actually, before doing this, I'm going to create a new folder, which is going to be on my working path. I'm going to create a Go folder for all my Go projects, and then I'm going to create the mandatory Hello World project. So as you can see here, we are in a new folder. I'm going to start Tmux in this location. So you see here Tmux. So at least we have a multiplexer to work with. I'm going to change the name of this tab to code, and then I'm going to show the most interesting feature of this, which is Neovim. For this, I'm going to start a Go project using Go mod init. I'm going to use github.com/messyrandom, which is my user, and hello. Of course, I'm not going to push this project into any repository. This is just for the sake of this example. And then I'm going to create an empty file called main.go, and it has a purpose. So now I'm just going to start Vim in this location. When I'm saying Vim, this is just an alias for Neovim, so that's it. This is going to take some time, but this is built upon lazy Vim. That's why you are seeing here this installation. This is going to happen just the very first time, as this is loading everything that I need to work with Neovim for this setup. So you can see here that it is installing all the necessary packages, even the theme, and it's loading everything. So I'm just going to wait for it to load everything. Now that everything seems to be installed, I'm just going to quit this, and it is still downloading some stuff here. So let's see what it's doing here. to make sure, I'm going to update everything. Okay, now I am sure that everything is done. Now I'm going to quit for a moment and I will start again. And now I'm just going to start working with the Go file. So by opening this one, I'm going to open Mason, which is like the package manager for all the things that are related to code. So here you are seeing that Mason is actually installing things that I need to work with programming language. In this case, it's installing Delph, which is going to be the debugger for Go, Go imports, Go please, and other stuff that I have defined on my configuration file. This is done automatically, so I'm just going to stop the video for a moment while it finishes installing everything. Okay, Mason has just finished installing all the things that it needs, so I'm going to quit this. I'm just going to quit this again, and I will start working on my example. So if I go to the main Go file, I'm just going to create a dummy thing. So let's start writing pkh, and the good thing is that all the Mason installation install these kind of easy things that helps you to code. So now I'm just going to write fmt. If I press enter, it automatically imports the package and I can use the function that I need. I'm going to invoke this read function that doesn't exist yet. I'm going to pass a string, which is my name, and of course you see here that this greet function doesn't exist. So I'm going to invoke the code actions, and I'm going to create the function greet, which is the option 1. So it creates the function. I can change this parameter here, so I'm going to use message. I'm going to change any for string, which is what I need to return. I will delete this line and I will return just an empty string. That's it. And I will save it. Of course, if I need to run this, I have several methods here. I will show one of them, which is calling the terminal, which is integrated in Neovim. I will just type go run dot. Of course, it doesn't print anything because I haven't written a useful code. So now I'm going to do just some tests. I'm going to invoke the code actions and I'm going to create the test for the read function. So you see here that the main test Go file has been created. I'm going to jump into that file. I will do the following action. So I'm going to delete this. It automatically detects that this test is inside the same package. So I'm just going to save the file and it automatically will remove the unnecessary dependencies. That's something that I really like from this. I'm going to remove also this thing here, and I won't save. You will see here that the save is unsaved, but if I go here, by the way, this video is going to show everything that I'm writing here in this blog post. So if you are curious about the whole process, you can go into this blog entry, which is called Working Environment Bootstrapper. So everything that I made to build this configuration is here. And now I'm going to assert testify go, which is the assertion package that I use in Go. So I'm just going to copy this one. Here I'm going to paste that one. And I'm going to also invoke the terminal here because I need to tidy this, so this is going to force downloading that, and finally I can delete this and write assert equal. I pass the testing object, the one. You can see here that I wrote WAN and it automatically recognizes where it's at. The same for this, and then I can write some silly things here to work with this. So I will remove this. I will create testing here. So again, I'm going to invoke the code actions so I can fill the anonymous structure here. So I will get rid of this one. And what I expect here is hello world. And again, the same is going for this one. I'm going to make the program to greet me. And that's it. So I'm going to store this. I'm going to exit for a moment, just to give it the opportunity to load everything correctly. And something that I really like from this setup is that I can get all the tests for this. I'm going to show the summary. The summary detects all the tests that I have here. So for example, if I jump from one subtest to another, it gets bolder in the testing summary. I'm going to test everything. This first running is going to take a little bit more because of course it has to download certain dependencies, but once it has done that, every test is going to be faster. So of course, as I haven't anything coded yet, both tests are expected to fail. This is the normal TDD development process. So I'm just going to wait for the test to fail. And now that they have failed, you can see here that I have a summary of what have failed. This is very useful because it says where it failed, what was I expecting and what I got. And let's go to the file and let's fix something. So I'm going to make one of those to pass. Actually, I'm not going to say because this is something that I coded here. If I change the buffer, it gets automatically saved. So if I run all the tests again, now this time is faster, you see that the first test has passed because it is returning what I expect, but the second doesn't because it got another completely different thing. So let's fix that. Now I have provided this installation with some useful things. For example, I can enclose this inside a parenthesis. Actually, and then I can call the fmt package to the sprintf function, then I can go to the word and replace it by a %s and pass the message, which is the thing that I need. If I change the buffer, the file is automatically saved, so I can run all the tests again, and here I see that my test passed. But let's see something even more interesting. I will close both the test summary and the explorer, and now I'm going to go to the line 28 where the grid invocation is, and I'm going to use the debugger to set a breakpoint here. Now that I have the breakpoint here, I can start any of these tests. So for example, let's say that I want to test either the default greeting subtest or the greeting a person. I'm going to use the greeting a person subtest. Now I'm going to go to the test and run the debugger for this test. So the first time is going to take just a moment because it's loading the debugger. In Mac, actually, you have to give permission to the debugger, so it's going to probably ask for your sudo password or your fingerprint if your Mac is provided with fingerprint reader. And here it is. So we have the debugger console here, so I can see here all my variables, the stacks, and everything. I can use the mouse, so here I'm going to use the mouse to click into the step into button. It takes me here. Some nice features is not only that I can see here the value of the variable, but it appears here, so this is useful. And I also can do a step over, or I can do step over using the debugger commands that I have here. So over is just a normal O, and I can even go deeper with the step into, which is going to take me to the sprintf function in the standard library. I can do some step over, step out, so I can go back to my test, step over, and I can even click on continue, so it's going to end the test. And this is it. I hope you find this useful and that you have liked it. Thank you.